So let's take a look at our first problem. What is the y-intercept of the line shown? Okay, we want to see the y-intercept. That's just like saying in a table, when x is 0, what is y? Okay? And we can do that by reading the graph. So here's the y-axis, goes right down the middle. Okay, the x-axis goes back and forth. And we're going to remember that usually x is time and y is something else, temperature, money, legs of animals. We have no idea right now. It's not specified in this program, or excuse me, in this question. Okay, what we do know is that the line crosses the y-axis at 3. So that would be the right answer. Okay. We want to read the graph, count if you need to, 1, 2, 3, up the y-axis. Okay, and again, if we're looking at a table of the function with x as the input, y as the output, when x is 0, y has to be 3. There are some other things that I can tell about this function just by looking at the graph. This is a positive slope, not a negative slope. And if I wanted to, I could actually work out an equation for this just based on the graph. I know if I look to the intersection points about what the slope will be, a rise of 1, 2, and a run of 1, 2, 3, 4. Rise of 2, run of 4 will make our fraction rise over run. That's going to be the same as 1 over 2. And I can put that in a form that relates y to x with a slope of 1/2 crossing the y-axis at 3. That would be the slope for this line. That goes way past what the question is actually asking. Again, they just want to know in this one, hey, where does the line cross the y-axis? And the correct answer is 3. Let's take a look at another problem. Two quantities are related. That's the key word there, related, right? Right away, we know we're talking about a function. Oh, a related as shown in the table, right? Here's x, here's our input, here's y, here's our output. And there's a lot that we can learn right away about slope and about y-intercept. It doesn't show us what y will be when x is 0, but we could certainly figure that out by looking at the pattern, the jump between points on the graph. But let's finish reading the question and make sure we understand what they're asking. Which equation best represents the relationship? Okay, so we are going to need to know slope, rise over run, and we are going to need to know y-intercept. Okay, because you need both of those things to make a successful equation. All right, let's see if we can figure this out. There's a pattern to the x's right now. 2, 4, 6, 8. Okay, so we can make a pretty good guess about what x will be, or excuse me, what y will be when x is 0. I'm going to cut this out and paste it back in, but I'm going to paste it back in just a little further down so we have some room to work. Let's switch over to black here. When x is 0, what will y be? Well, we should go and see, is there a pattern to the y's? 2 to 5, that's a jump of 3. 5 to 8, oh, jump of 3. 8 to 11, jump of 3. There we go. So if 2 minus 3 takes us down to negative 1. When x is 0, y will be negative 1. That is our y-intercept. So right away, I know whatever else I have for the equation, at the very end, it's going to be minus 1. Okay? We'll get there. Now, the other thing that I need to know is the slope of the line. Okay? What kind of slope can I get from these points? And to do that, I need 2 points to subtract. So I'm going to use these first 2 points. I better switch colors now because we're on to a different concept here. This part's going to be our slope. There's a good blue. All right, we'll use these 2 points, 4, 5, and 2, 2. And I'm going to put the y's on the top. I'm going to take this y minus that y. Okay, 5 minus 2 divided by the x's, 4 minus 2. This is like subtracting 1 point from another. So that's 5 minus 2, that's 3 over 4 minus 2, that's 2. 3 over 2 is not a fraction that I can reduce or simplify anymore. It just has to be what it is. That's our slope. So we have an equation of y is the same as 3 over 2 minus 1. And I've done it in the same colors, right? That's my y-intercept. And the 3 over 2 is my slope. Now we want to see if this equation matches up with anything over here. And it looks like when I pulled this example, this student picked plus 2 as the y-intercept, which is easy to do because the first value on the table is a plus 2. But that's not the right answer. We know that when x is 0, y has to be negative 1. 3 over 2 times x minus 1. That's our right answer. That's our best representation of the relationship. Now, as a mathematician, it's really important to feel sure of your answers. And to do that, you're going to have to solve the question at least 2 ways. Or work with a partner. Work with somebody else who's solving it on their own and compare your answers. Okay? We feel good about our answers when we compare, when we check our problems. That's the only way we can be confident in our solution as mathematicians. So we'll switch over to Desmos and we'll drop in our equation. Y is the same as 3 divided by 2 times x minus 1. That's what that line looks like. And we can drop in a table of points to double check and see. On the x, we have a pattern of 2. So 0, 2, 4, 6. And on the y, we have a pattern of 3, negative 1, 2, 5, 8. And if this function lines up with that table that we were originally given, then they're a good match. And I think looking at the function and the table and the graph, we've got a good match. We should feel good about this solution. We got it right.